So unlike the previous demonstrations, whether it is a static knowledge base or a dynamic knowledge base is actually available only when the application is running. So we haven't seen how we can maintain the persistent storage of the vector database. So let's see how we can do it. So I am taking Mistelbot as an example, which we have seen in the static knowledge demonstration. The key part of this caching lies in the vector data store, which we discussed in previously, where we have the key building blocks of vector database like FEISS, sentence transformer. I mentioned previously, we'll be discussing in the later phase of the demonstration. So this index path is actually a vector database path, and this mapping path is metadata's file path. As I left a comment here, we simply uncomment this to load the documents, and at the time of adding the documents, we simply uncomment this to save the documents. So what this will do is, as soon as when we try to load the documents, then internally it triggers this add documents. Previously, we are maintaining metadata in the live memory. Once after updating the live memory, we are handing it over to save the documents to database file, which is located physically in our system. So let's see what does this save document actually does in first place. This save document takes the FAS reference and it writes the available index of the current index. Self.index holds the latest information up to date, as in when the data comes to this vector data store, it's get added to the index in the form of embeddings. So this will be available in index, and we give this reference and the index path, both will be given here to the FASS to write it. This index path is a database file path. The FASS takes care of it to store the entire vector database into this file path, and I am using Pickle to save the metadata. Instead of this, we can also go for the traditional databases. So this is just an option. For me, it is easy to use at this point of demonstration and experimentation. So that's why I went for Pickle. It dumps the metadata into whatever is given in this mapping path. Now, after doing this, whatever documents we have given along with that metadata and vector database references are permanently stored in our systems. So that's how we cache the information in our local system. Now, let's see how we actually load the information. So load documents is similar to any other kind of file operations. Previously, we wrote the information to given index path or a mapping path. Now we are going to read the information from the given index path and mapping path and hold their references. Post that, when we start retrieving, the queries will go how they worked previously. There won't be any difference to that because we cache the indices and the doc store references. The same will be retained from the cached databases. Our queries will be executed. I would like to add a bit comment here. So because I made it as a generic one to demonstrate both persistent and non-persistent, so we need to tweak this a bit. I will be doing that change now. I have given a clear instruction here where we actually call this knowledge load. At the time of experimentation from your side, you can make this change and make it run. To demonstrate how we persist the storage, I will load the documents. I haven't cached anything, so I will leave it uncommented. First time, I will uncomment the saved documents. First, it will save the documents. Next time I run the application, I will comment this, because if I don't comment, then the documents will be fed back to the vector data store from the RAG pipeline. There is no logic here in place to identify whether document is already cached or not. Ideally, we can have as an enhancement to this. So let's run the application now. I'm running the same Red Riding Robin Hood story now. So this is where the static knowledge, the little Red Riding Hood is actually, and this is the vector data store. Right now there is no information cached at this point. Let's see the same physical path once we run the application. Let me clear this. Python, yeah, same script I'm running. Application is running now. Now let's go and check the physical directory of our vector data store of the static knowledge. So here in our project directory, we are seeing two freshly created files from the knowledge base what we fed from the static knowledge. The data is cached, so I won't be running any query now. I will just exit. Then I will, so now let's comment this line where we actually give the document directory and save it. Let's run this application and see how the persistent storage actually works. Earlier we haven't asked any question because that time we are loading the document into the persistent storage. Let's ask who is the lead character in the Red Riding Hood story. Seems it identified the semantic search from the vector database. Okay, the lead character in the Red Riding Hood story is Little Red Riding Hood. Okay, yeah, that is correct. Let's ask who is Red Riding Hood is helping and why. So here the fairy tale Little Red Riding Hood helping her grandmother who is sick. She carries a basket of food and other items to her grandmother's house, which is in the woods. Here's something this model hallucinated. It shared like 90% of the answer is actually from the given context. Basically, model is able to point to the persistent storage which is saved in the previous run. So now the context or the knowledge base is fed from the persistent storage, and that's how a persistent storage works in the RAG pipeline.